Good day everyone, so I am Michaela Esther from section Our Lady of Light. Today I will share what I've learned from the video that our teacher showed us. So in the first video, it talks about the first law of thermodynamics and how it relates to internal energy, heat, and work. And for the second video, it talks about calorimetry calculations. So let's start with the first law of thermodynamics. So energy can't be created or destroyed. It's simply transferred from one place to another. So as you can see here, this is system, and everything outside of it is surroundings. So energy can flow or out of the systems, and as two ways in which it can do so, and that's through heat and work. So if heat flows into the system, gains energy, and that energy is known as internal energy, represented by the symbol capital U. Now the surroundings can do work on a system, so those are the two ways to which a system can increase its internal energy. So for example, let's say if the surroundings have performed 500 joules on the system, that means the system internal energy goes up by 500. So the change is positive. So delta U increases the energy of the surroundings, has to decrease 500, and so energy is not created or destroyed, or is simply transferred from one place to another. So the system didn't just get 500 joule from nowhere. That 500 joule from energy came from somewhere. It comes from the surroundings. So a good way to illustrate this is use the money. So for example, in order for you to gain 1,000 pesos, someone else has to lose 1,000 pesos. So in this case, within the transaction, money is not created or destroyed. It's simply transferred from one place to another. So in the example, back to the example here, so energy is simply transferred from one place to another. So if the system gains 500 joule energy, that means the surroundings loses 500 joules of energy. So there are three types of system. So first is open system, second is closed system, and last isolated system. So for open system, so matter or oxygen can enter into an open system, and also heat energy can flow into an open system. So matter and energy can be transferred into or out of an open system. So while closed system, matter cannot flow into it, so oxygen just can't go inside. However, energy can still flow into a closed system. While isolated system, so matter or energy can't enter or leave an isolated system. So the mass within an isolated system is fixed. It doesn't change, and also energy, because no energy can flow into or out of it. So the equation for the change in the internal energy of a system is delta U is equal to Q plus W. That's for chemistry. So Q represents the heat of energy that flows into or out of the system, while W represents the work. So in physics, its equation is a bit different from chemistry. So as you can see, delta U is equal to Q minus W. So, as you can see, here, the equation of chemistry and physics. So, in chemistry, W is negative when work is done by the system. So, the internal energy is decreasing. And when work is positive, then the work is done on the system. So the internal energy is still decreasing. However, W is positive because the surrounding is gained and energy was taken from the viewpoint of the surroundings. So while physics, it's different. So we take the surroundings point of view. So when W is negative, work is done on the system, while work is positive, so W is done by the system. So in the chemistry, we take the viewpoint of the system, while physics take the viewpoint of the surroundings. So when work is done by the system loses energy, the surroundings gain energy. So for the second video, which is calorimetry calculations. So calculations involving heat and the change in temperature resulting from heat being either absorbed or lost by substance. So in order to calculate the heat gained or lost by a substance, we need to know the specific heat capacity, which is given the symbol as. And this is defined as the energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius, and temperature are not the same thing, but adding heat to a substance causes its temperature to go up, and the specific heat capacities, it gives the relationship different substances have different specific heat capacities. Some need a great deal of heat in order to increase their temperature, while others only need a small amount of heat to increase their temperatures, which leads to actually a very simple equation. So, for calculating heat gained or lost by a substance, heat given the symbol Q is equal to mass of the substance times specific heat capacity times the change in temperature. And in this case, change of T is always going to be defined as the final temperature minus initial temperature of the substance. So the final temperature where it arrived after it absorbing or losing heat, while initial temperature where it is started before it gained or lost heat. So signs of heat. So if Q is less than 0, so or in negative number, so this means that the temperature has gone or decreasing, losing heat. So if Q is positive or greater than 0, this means that the temperature is rising or increasing, and this substance is gaining heat. We have an example here. So as you can see, so here, how much heat is needed to raise the temperature of 200 grams of water from 30 degrees Celsius to 70 degrees Celsius. So we have here the given. So the specific heat capacity is equal to 4.18 joules per second degrees Celsius. Mass is equal to 200 grams. So for the change of temperature, we need to minus the final temperature to initial temperature. So 70 degrees Celsius minus 30 degrees Celsius. So the change of temperature is equal to 40 degrees Celsius. So solution. So Q is equal to S times M times change of T. So Q is equal to 4.18 joules, joules per grams degrees Celsius times 200 grams times 40 degrees Celsius. Q is equal to 3,440 joules or 33.44 kilojoules. And that's all for now. And thank you and God bless.